I'm reading some more from Calculus Made Easy. The other video I had to stop shortly around this area, and I was having trouble with the screen recorder. It didn't want to record a PDF, so fortunately this website I found where somebody's done and made the book into a sort of clickable website so we can do this. Off we go. Now, if we fix upon any numerical fraction as constituting the proportion which, for any purpose, we call relatively small, we can easily state other fractions of a higher degree of smallness. Thus, if, for the purpose of time, 1/60th be called a small fraction, then 1/60th of 1/60th, being a small fraction of a small fraction, may be regarded as a small quantity of the second order of smallness. The mathematicians talk about the second order of magnitude, i.e. greatness, when they really mean second order of smallness. This is very confusing to beginners. Or, if for any purpose we were to take 1%, i.e. 1/100th, as a small fraction, then 1% of 1%, i.e. 1/10,000th, would be a small fraction of the second order of smallness. And 1/1,000,000th would be a small fraction of the third order of smallness, being 1% of 1% of 1%. Lastly, suppose that for some very precise purpose we should regard 1/1,000,000th as small. Thus, if a first-rate chronometer is not to lose or gain more than half a minute in a year, it must keep time with an accuracy of 1 part in 1,051,200. Now, if for such a purpose we regard 1/1,000,000th or 1/1,000,000th as a small quantity, then 1/1,000,000th of 1/1,000,000th, that is, 1/1000 billionth or 1/1000th will be a small quantity of the second order of smallness and may be utterly disregarded by comparison. Then we see that the smaller a small quantity itself is, the more negligible does the corresponding small quantity of the second order become. Hence, we know that in all cases we are justified in neglecting the small quantities of the second or third or higher orders, if only we take the small quantity of the first order small enough in itself. But it must be remembered that small quantities, if they occur in our expressions as factors multiplied by some other factor, may become important if the other factor is itself large. Even a farthing becomes important if only it is multiplied by a few hundred. Now, in the calculus we write dx for a little bit of x. These things such as dx and du and dy are called differentials. The differential of x or of u or of y, as the case may be. You read them as dx or du or dy. If dx be a small bit of x and relatively small of itself, it does not follow that such quantities as x dx or x squared dx or a to the x dx are negligible. But dx times dx would be negligible, being a small quantity of the second order. A very simple example will serve as illustration. Let us think of dx as a quantity that can grow by a small amount so as to become x plus dx, where dx is the small increment added by growth. The square of this is x squared plus 2x dx plus dx squared. The second term is not negligible because it is a first-order quantity, while the third term is of the second order of smallness, being a bit of x squared. Thus, if we took dx to mean numerically, say, 1/60th of x, then the second term would be 2/60ths of x, whereas the third term would be 1/3600th of x squared. This last term is clearly less important than the second. But if we go further and take dx to mean only 1/1000th of x, then the second term will be 2/1000ths of x squared, while the third term will be only 1/1,000,000th of x squared. Geometrically, this may be depicted as follows. Draw a square, figure 1, the side of which we will take to represent x. Now, suppose the square is the square to grow by having a bit dx added to its size each way. The enlarged square is made up of the original square x squared, the two rectangles at the top and on the right, each of which is of area x dx, or together 2x dx, and the little square at the top right-hand corner, which is dx squared. In figure 2, we have taken dx as quite a big fraction of x, about a fifth. But suppose we had taken it only 1/100th, about the thickness of an inked line drawn with a fine pen. Then the little corner square will have an area of only 1/10,000th of x squared and be practically invisible. Clearly, dx squared is negligible if only we consider the increment dx to be itself small enough. Let us consider a simile. Suppose a millionaire were to say to his secretary, "Next week I will give you a small fraction of any money that comes into me." Suppose that the secretary were to say to his boy, "I will give you a small fraction of what I get." Suppose the fraction in each case to be 1/100th part. Now, if Mr. Millionaire received during the next week £1,000, the secretary would receive £10 and the boy 2 shillings. £10 would be a small quantity compared with £1,000, but 2 shillings is a small quantity indeed, of a very secondary order. But what would be the disproportion if the fraction, instead of being 1/100th, had been settled at 1/1000th part? Then, while Mr. Millionaire got his £1,000, Mr. Secretary would get only £1, and the boy less than 1 farthing. The witty Dean Swift once wrote, "So naturalists observe a flea hath smaller fleas that on him prey, and these have smaller fleas to bite 'em, and so proceed ad infinitum." On Poetry, a Rhapsody, page 20, printed 1733, usually misquoted. An ox might worry about a flea of ordinary size, a small creature of the first order of smallness, but he would probably not trouble himself about a flea's flea, being of the second order of smallness. It would be negligible. Even a gross of flea's fleas would not be of much account to the ox. Well, there we are, the first 2 chapters of this very interesting calculus book. Today I was reading from calculusmadeeasy.org. And you can see that this is the sort of book that still has interest nowadays, in that somebody took the trouble to digitize it for the web in such a way. And I've seen many reviews that say that it stands up to modern practice in a lot of ways. So there you have it. I hope you enjoyed.